There was once a time when the skies belonged to creatures with wings wider than a small airplane. Vast floodplains echoed beneath the footsteps of animals taller than five-story buildings. Forests trembled as predators with bone-crushing jaws stalked the shadows, while armored giants, horned defenders, and long-necked titans shared an earth almost impossible to imagine today. Among them soared Quetzalcoatlus, one of the largest flying animals ever discovered. Its fossils emerged from the deserts of Big Bend National Park in Texas, United States, revealing a flying reptile with a wingspan approaching 36 feet, large enough to glide over entire herds without flapping for long distances. Scientists believe it could launch itself into the air with astonishing efficiency before silently patrolling ancient coastlines and inland plains in search of prey. Far below walked Tyrannosaurus rex, whose most famous skeletons were unearthed from the Hell Creek Formation of Montana, South Dakota, and Wyoming in the United States. Stretching nearly 40 feet in length and armed with teeth the size of bananas, it possessed one of the most powerful bite forces ever measured in a land animal. Every scar found on fossilized skulls hints at violent territorial battles, suggesting that these predators did not merely hunt. They fought rivals for dominance in a world where strength often determined survival.
When the same kinds of fossils appear on different continents, inside rock layers of the same age, coincidence is no longer an explanation. That's scientific evidence.
Towering above them was Brachiosaurus, first discovered in the Morrison Formation of Colorado in 1900. Unlike most dinosaurs, its front legs were longer than its hind legs, lifting its shoulders high above the ground like a living observation tower. Its immense neck allowed it to browse the tops of conifer forests that few other herbivores could reach, consuming hundreds of pounds of vegetation every single day. Across what is now Mongolia's Gobi Desert, another remarkable dinosaur waded beneath the sands for over 70 million years. Velociraptor was nothing like the giant monster portrayed in popular films. Barely the size of a turkey, it was swift, intelligent, and almost certainly covered in feathers. Fossils preserving the famous sickle-shaped claw on each foot reveal a predator built for speed, precision, and ambush rather than overwhelming strength. In Patagonia, Argentina, paleontologists uncovered the remains of Argentinosaurus, an animal so enormous that even today no complete skeleton has ever been found. Yet the bones recovered suggest a creature exceeding 100 feet in length and weighing perhaps 70 tons, making it one of the largest land animals known to have ever lived. Standing beside a single fossilized vertebra is enough to make a grown adult appear like a child. Then there was Triceratops, recognized by 3 imposing horns and an immense bony frill surrounding its neck. Hundreds of fossils recovered throughout Western North America suggest it traveled in groups, grazing across broad river plains while relying on its horns not only for defense against predators, but also for contests within its own species. Each of these animals lived in different environments, at different times, separated by millions of years. Some thrived in humid forests, others crossed dry floodplains, while still others nested beside ancient rivers that disappeared long before humans existed. At first glance, their stories sound almost too extraordinary to be true. Flying giants, house-sized herbivores, predators capable of crushing bone with a single bite. Animals unlike anything alive today.
What convinces scientists isn't one spectacular skeleton. It's millions of independent discoveries, collected over centuries, all pointing to the very same conclusion. Dinosaurs were undeniably real.
For centuries, many believed such creatures belonged to mythology rather than natural history. Yet today, virtually every scientist on Earth accepts that these extraordinary animals were real, not because of imagination, not because of ancient legends, but because the Earth itself has preserved an overwhelming collection of evidence so detailed, so consistent, and so remarkable that it transformed one of history's greatest scientific mysteries into one of its greatest discoveries, and that evidence begins with a stone. For most of human history, no one knew what dinosaur bones truly were. When enormous fossilized bones emerged from cliffs and riverbanks, they were often mistaken for the remains of dragons, giants, or mysterious beasts described in folklore. Across Europe, Asia, and the Middle East, oversized fossil bones inspired legends that survived for centuries. Without geology, without evolutionary biology, and without modern anatomy, there was simply no framework for understanding animals that had vanished tens of millions of years before humanity appeared. Everything began to change during the early 19th century. In southern England, beneath layers of Jurassic limestone, physicians, geologists, and fossil collectors started uncovering skeletons unlike anything alive. One of the first was Megalosaurus, formally described in 1824 from fossils discovered in Oxfordshire. Shortly afterward came Iguanodon, identified from enormous fossilized teeth found in Sussex, followed by Haleosaurus, an armored giant whose body carried rows of protective spikes. Individually, these discoveries were astonishing. Together, they revealed something revolutionary. These animals shared anatomical features that no living reptiles possessed, yet they also displayed remarkable similarities to one another. Their hips, limbs, vertebrae, and skulls followed repeating biological patterns, suggesting they belonged to an entirely separate group of ancient animals.
Dinosaurs didn't become real because we believed in them. They became undeniable because the Earth never stopped telling their story.
In 1842, British anatomist Sir Richard Owen carefully compared these fossils in extraordinary detail. Instead of treating them as unrelated monsters, he recognized that they represented members of a completely distinct lineage. He introduced a new scientific name derived from Greek words meaning terrible lizards, Dinosauria. That single word marked the birth of dinosaur science. But naming them did not automatically convince the world. Extraordinary discoveries demand extraordinary proof. Many scientists remained skeptical because only fragments of skeletons had been found.
People often imagine dinosaurs as monsters, but the evidence shows they were real animals, with complex behaviors, ecosystems, and lives remarkably similar to modern wildlife.
Could these bones simply belong to unusually large crocodiles, giant lizards, unknown mammals? Until complete skeletons appeared, uncertainty remained. Then came one of the greatest turning points in paleontology. In 1878, deep beneath a coal mine near the village of Bernissar, Belgium, miners accidentally struck something unusual nearly 1,000 feet below the surface. Instead of coal, they uncovered dozens of enormous fossil skeletons buried together inside ancient rock. The mine was immediately transformed into a scientific excavation. Over the following years, researchers carefully removed more than 30 remarkably complete iguanodon skeletons.
The rocks have no reason to invent a story. Yet everywhere we dig, they preserve the same extraordinary history of a world ruled by dinosaurs for millions of years.
one of the largest dinosaur discoveries ever made. For the first time, scientists could examine entire bodies rather than isolated bones. The skeletons answered questions that had puzzled researchers for decades. They stood on powerful hind legs while balancing with long muscular tails. Their forelimbs were shorter but flexible enough to grasp vegetation. The famous thumb spike, once thought to be a horn attached to the nose, was actually mounted on the hand, probably serving as a defensive weapon against predators. Every joint connected naturally. Every vertebra aligned perfectly. Every limb matched the mechanics expected of a living animal. Nothing appeared random. Nothing resembled myth. The skeletons looked exactly like creatures built by evolution, not imagination. As paleontologists expanded their work across North America during the late 1800s, the evidence became impossible to ignore. The Morrison Formation, stretching across states including Colorado, Utah, and Wyoming, revealed an entire prehistoric ecosystem preserved in the stone. Here lay the gigantic Diplodocus, whose whip-like tail extended almost half the length of its body. Nearby rested Stegosaurus, carrying double rows of towering plates along its back and spikes powerful enough to repel predators. Then came Allosaurus, a formidable hunter whose sharp teeth, muscular legs, and forward-facing vision painted the picture of an apex predator perfectly adapted for pursuit. These animals weren't discovered one by one in isolation. They were found together. The predators appeared in exactly the environments where herbivores were buried.
A single footprint can reveal an animal's speed. A healed bone can tell us it survived an attack. Fossils don't just show us what dinosaurs looked like, they show us how they lived.
Young individuals were found alongside adults. Eggs appeared near nesting grounds. Ancient river channels preserved entire communities frozen in time. It was no longer just about gigantic skeletons. Scientists were beginning to uncover complete ecosystems. An entire world had existed long before humanity. A world whose forests, rivers, predators, prey, and seasons had all been recorded inside layers of ancient rock, waiting patiently for millions of years until someone finally learned how to read them. If dinosaur skeletons were the only evidence we possessed, there would always be room for doubt. A skeleton tells us what an animal looked like, but it cannot by itself explain how it moved, how it hunted, whether it cared for its young, or what kind of world it inhabited. Fortunately, the Earth preserved far more than bones. It preserved moments, entire scenes from prehistoric life frozen in time. One of the first clues came not from a skeleton, but from the ground beneath it. Across ancient rock surfaces, on nearly every continent, paleontologists began discovering enormous trackways. Thousands upon thousands of fossilized footprints, each one stamped into soft mud millions of years ago before hardening into stone. Some trackways stretch for miles, crossing riverbanks that disappeared long before the first humans evolved. These footprints were unlike anything produced by living animals. Some measured more than 3 feet across. Others belonged to tiny feathered hunters no larger than modern birds. When scientists carefully mapped these tracks, fascinating patterns emerged. Large herbivores often traveled in parallel lines, moving in the same direction at similar speeds. Smaller footprints frequently appeared surrounded by larger ones, suggesting juveniles remained protected within the center of the herd, while adults walked along the edges. It was behavior remarkably similar to elephants crossing the African savanna today. Predator tracks revealed an entirely different story. Their footprints were narrower, their stride lengths were longer, their claws dug deeper into soft sediment, indicating powerful acceleration. Some trackways suddenly changed direction, while nearby herbivore footprints scattered in every direction. Although the chase itself vanished more than 100 million years ago, its final moments remained recorded beneath layers of stone. Then came something even more extraordinary. In northeastern China, within the exceptionally preserved rocks of Liaoning province, scientists uncovered fossils unlike any previously discovered. Surrounding the skeletons were delicate impressions that resembled fine strands extending from the arms, necks, and tails of small predatory dinosaurs. At first, researchers questioned whether these markings were simply mineral patterns. Repeated discoveries proved otherwise. These were feathers, not attached to birds, attached to dinosaurs. Species such as Sinosauropteryx, Microraptor, and Caudipteryx demonstrated beyond reasonable doubt that feathers evolved long before modern birds dominated the skies. Some possessed simple hair-like filaments used for insulation. Others displayed complex flight feathers almost identical to those seen in birds today.
One of the greatest discoveries wasn't simply finding dinosaurs. It was realizing that birds are their living descendants. In many ways, dinosaurs never completely disappeared.
The discovery transformed one of biology's greatest mysteries. Birds were not merely relatives of dinosaurs, they were dinosaurs, living descendants of a lineage that survived the mass extinction, while their larger relatives disappeared forever. Then the rocks offered another surprise. In Montana, paleontologists excavating the famous Two Medicine Formation uncovered entire nesting grounds belonging to a duck-billed dinosaur known as Maiasaura, whose name means good mother lizard. Dozens of nests appeared carefully spaced from one another, each containing broken eggshells and the delicate bones of hatchlings. The young were far too underdeveloped to leave the nest immediately after hatching. Their leg bones had not fully matured. Their joints were still growing. Their teeth showed evidence of repeated feeding rather than immediate independence. Only one explanation fit the evidence. The parents had remained behind to care for their offspring. For decades, popular culture imagined dinosaurs as slow, unintelligent reptiles driven purely by instinct. The fossils painted a very different picture. Some nested in organized colonies. Some protected their young. Some traveled in herds. Others hunted with speed, coordination, and remarkable precision. Even injuries told stories. Scientists have found healed fractures, bite marks that later recovered, arthritic joints, bone infections, and even evidence of tumors preserved within fossil skeletons. One famous Tyrannosaurus rex specimen carried healed wounds across its skull, indicating it survived violent encounters with rivals long enough for the injuries to mend. Another dinosaur bore the unmistakable tooth marks of a predator that attacked but failed to kill it. The victim escaped, healed, and lived on. These were no longer lifeless fossils. They had become biographies. Each scar spoke of survival. Each footprint recorded a journey. Each feather revealed an evolutionary connection. Each nest preserved the instincts to protect the next generation. By now, the evidence extended far beyond gigantic skeletons buried underground. Scientists were no longer reconstructing individual animals. They were reconstructing entire lives. And with every remarkable discovery, the ancient world became just a little less mysterious and a little more real. Science is built on one principle above all others. A single discovery can be questioned. 100 discoveries can still be debated. But when millions of independent pieces of evidence all point toward the same conclusion, skepticism gives way to certainty. Today, dinosaur fossils have been discovered on every continent, including Antarctica. From the frozen polar rocks of the south to the deserts of Mongolia, the cliffs of England, the badlands of North America, the vast plains of Argentina, and the ancient sedimentary basins of China, each excavation continues to reveal animals that fit perfectly into Earth's geological timeline. The evidence does not come from one country, it comes from the entire planet. More importantly, every branch of science arrives at the same conclusion independently. Geologists study the rock layers containing dinosaur fossils and determine their age using radiometric dating, measuring the natural decay of radioactive elements trapped inside volcanic ash. Again and again, these methods consistently place non-avian dinosaurs between roughly 230 and 66 million years ago. The evidence did not convince scientists because it was dramatic. It convinced them because it was overwhelming. And beneath countless mountains, deserts, cliffs, and valleys around the world, that story is still being uncovered, one fossil at a time.
Every fossil we uncover is more than a collection of bones. It's a biological record, preserved by the Earth itself, waiting millions of years for someone to read its story.